Data warehouses are complex applications that present their development teams with complex quality assurance challenges. During development or maintenance programming, the developers need to test not only the new features that have just been added, but also the hundreds of features already implemented in the previous versions of the warehouse to ensure that the new programming has not diminished the application's existing capabilities. Zuzena is a test engine designed for data warehouses and other data-driven applications. In this set of screencasts, we will build an entire test case from scratch so that you will learn how to create, execute, and review tests using an automated test engine such as Zuzena. We organized these videos to be watched first as a series to see the full process of creating a test case. When later you wish to review just an individual step, use the links on this screen to travel to the individual video of interest. Before we start building the test case, let's quickly look at the major capabilities you'll want in a test engine and which you'll certainly find in Zuzena. Whereas Zuzena can be used to validate a wide range of data-driven applications, it was designed in particular to support teams building systems that provide data warehousing, business intelligence, and big data analytics. It provides a team's developers with a single, highly organized repository where they can author and update hundreds of tests using a single format that makes all the test cases readily understandable to anyone who looks inside the repository. By developers, we mean to say that Zuzena allows tests to be authored, executed, and reviewed by a wide collection of team participants, including architects, designers, and programmers, in addition to the members of the quality assurance function themselves. Zuzena supports user-defined metadata tags for such notions as subject area, architectural layer, load type, and error type, so that developers can systematically label the test cases in a repository. These labels allow the team to group the test cases into test suites. Later, the team can specify the desired values for some or all of these metadata tags, and thereby execute those test suites individually, then review the results of each test suite in isolation. The call that invokes a test suite can come from several places: someone using the Zuzena graphical user interface, or someone entering an operating system command directed to the Zuzena execution engine. Eventually, most test suites are invoked by commands submitted to the Zuzena engine by a process scheduler such as cron, Jenkins, or Control-M. When any of these agents request a test suite, Zuzena will execute the test cases within it. For each test case, Zuzena will prep the necessary data, call the appropriate data transforms with the correct parameters, and then systematically evaluate the outcome of those transformation steps. Developers and other stakeholders can then use a business intelligence tool to query the Zuzena repository to see reports and trend lines showing tests that have passed, failed, or errored during execution. See our video on evidence-based project status reporting to learn more about how Zuzena allows people to drill down into test results to uncover the root cause of a test suite failure. In this video series, we will build what is called a nominal test case. In a nominal test case for data warehousing, the starting situation is nominal. In other words, everything is lined up for a trouble-free run. The input data has been groomed so that all the data transformation features will work as expected. This situation is often referred to as the happy path test case. A full system test package will of course contain other tests that illustrate how the data transforms respond when confronted with non-nominal situations, such as improper values in the source data or references to non-existent business entities. Test cases typically have three components: data definitions, scripts, and evaluations. Data definitions are actions that prepare the warehouse data objects so they match the desired starting conditions. This typically involves staging source data into the data transforms landing tables. Sometimes the reference and target data tables of the data warehouse are also repopulated to simulate the situation expected at the start of an update process. Scripts represent the second component. They are commands to the extract, transform, and load engine, directing it to move data from the source tables and place existing and created values into the data warehouse's target tables. As the third component of a test case, evaluations provide the validation steps the test engine should follow in order to decide whether the data transform process has been performed as expected given the starting conditions. Evaluations can contain a large mix of assertions. Some of those assertions will be as simple as comparing an actual table to a table of expected results. Other assertions will be more analytical in nature, such as matching row counts between source and target data sets. The nominal test case we'll be building in this video series will validate a data transform that places a data set of revenue information into a summary star schema called weekly billings. This diagram depicts the data model of the sample, PABL, data that comes with every Zuzena installation. The PABL data represents a small telephone company and has reference entities in the source data for geographical markets, sales channels, customer segments, and products. For transactions, the PABL dataset has revenue records from 2 billing systems, one for the Northwest region and another for the Southwest. The second diagram shows the data model for the target data warehouse the data transforms will populate. The transforms will first use reference table data to update dimensions for date, product, sales channel, market area, and customer segment. They will then summarize and integrate the transaction data to load into the central fact table for weekly billings. In order to confirm that the data transforms have operated correctly, we have to first understand what they were meant to do. The PABL data transforms are housed in an ETL package that accepts a parameter for target billing date and then performs the following steps. Number 1, check for customer segment, market, product, and sales channel codes in the Northwest and Southwest billing transaction tables that do not have corresponding records in the reference tables, and raise an incomplete reference data exception if any are found. Number 2, load the dimension tables with any new reference table records. Number 3, populate a temporary work table with the sum of billing amounts for each unique combination of reference codes and for the target billing date. Number 4, clear the existing weekly billing fact table records for the target billing date. Finally, number 5, populate the weekly billing fact table from the temporary work table, assigning foreign keys that link each fact record to the appropriate dimension record for transaction date, product, customer segment, etc. So the data transforms we will be testing add reference entities to our star schemas dimension tables, then summarize and integrate 2 sets of billing data to the fact tables for a given calendar week. How should we test that this transformation completed successfully? In our example, we will illustrate both major types of assertions one can use: expected results and analytical statements. To validate that the dimensions were properly updated and linked to the fact table records, we will use an expected result. In this approach, the analysts preparing specifications for a data transform will identify some examples of properly transformed data they expect to see in the target tables when the ETL has been properly programmed. They will create a canned set of records for both source data and target data. The canned source records will be placed in the warehouse landing tables before the ETL is called. The canned target records will be placed in an expected results repository. When the ETL has finished executing, Zuzena will compare the actual results in the warehouse's target tables to the records in the expected results repository, progressing row by row, column by column, to ensure every cell holds the value it was intended to receive. To validate the values in the fact table, we will use an analytical assertion which states simply that the sum of the billing amounts loaded to the target tables equals the total billings from the 2 source tables. This assertion is sufficient because this is the nominal case. All records should load. In future test cases, we will want to do negative testing where unloadable billing records are sent to a suspense table rather than a fact entity. In that case, our analytical assertion will have to be amended to say that the dollar amounts in the source add up to the dollar amounts in the target and suspense tables. This first video of our sample test case demonstration has introduced you to automated testing for data-driven applications such as data warehouses. We have explained that you need a test case repository where your team's developers can store data prep steps, ETL calls, and quality assertions in an organized and widely accessible repository. We illustrated the basic algorithm that automated test engineers must follow: staging the data, calling the data transforms, and evaluating the assertions against the records loaded by the ETL. We also discussed how your repository should allow user-defined metadata tags so that you can organize your test cases into test suites, which can be executed and evaluated independently. We mentioned that Zuzena has all of these features and many more that will make your DWBI quality assurance process far easier, faster, and more robust. There are several remaining videos in this series. The next video will explain how to create the test case container and assign metadata tags. Use the links on this page to open any of the remaining videos. Be sure to contact us with questions concerning test automation for data warehousing, business intelligence, and big data application development. Thanks for watching this screencast, and good luck with your projects.